Okay, so in this video, we're going to talk about solving trig equations. This is arguably one of the most important things um, about trig that you're going to do going forward in calculus, is solving trig equations, finding out answers when a sine function equals a number, or you can see my second example here. Being able to solve those is really, really important. All of the tools we've gone through using, knowing our special triangles, our special angles, knowing our trig graphs, all of that plays into this. So it all kind of comes together and helps us solve equations. One thing to, I guess, acknowledge here, if I'm trying to figure out where the sine of x equals negative root 3 over 2, think about the sine function, the sine graph, which we know starts at the origin and does its little wavy thing and finishes one cycle by the time you get to 2 pi. But we know this sine graph goes on forever in both the positive and negative direction. And so if I was trying to find all of the answers where sine of x equals negative root 3 over 2, negative root 3 over 2 is something maybe about right here. You can see that there's actually an infinite number of places where negative root 3 over 2 intersects the graph of y equals sine of x. So most of the time when you're solving a trig equation, there's actually an infinite number of solutions. So to limit ourselves, what we usually do is just ask for the solutions between 0 and 2 pi, for which you can see there's going to be 2 places where negative root 3 over 2 intersects the graph of y equals sine of x. Now, how do we find those 2 places? Another thing we've talked about, according to all students take calculus, sine we know is positive in the first and second quadrants, all in sine. So if sine was equal to negative root 3 over 2, that could happen in either the third quadrant or the fourth quadrant. So let's just acknowledge that right now. It's either going to be in quadrant 3 or in quadrant 4. So then what we could do is sketch a triangle in the third quadrant. Remember when we were using reference angles, by evaluating trig functions using reference angles. So imagine this is inside a circle. So x itself would be the angle that starts from here to here. That's x. That's what we want. But we know it's all about the reference angle. So I can use my value of sine. If sine is opposite over hypotenuse, this side must be negative root 3. This side must be 2. This, hopefully you recognize those numbers. That number would be 1. By the way, highly recommend this. Just put this on a note card. This is all of the information, really, other than identities, that you need to solve trig equations and evaluate trig functions. If you can get those 2 triangles down, which we've been working on, and also know the graphs of sine and cosine, you can answer almost everything you need to. So it might be a good idea to see if, make sure you can reconstruct a note card, study it in your free time, because that's one of our special angles. And we know that the angle that goes opposite the root 3 is pi over 3. So I know that this angle right here is pi over 3. However, x has to start from 0 on the positive x-axis. So how do I find x? Well, if I go all the way from here to here, we know that's equal to pi. And I'm going to think of pi as 3 pi over 3, and then add pi over 3 to that to get to the hypotenuse. I want to go from here and then add that pi over 3 in. And 3 pi over 3 plus pi over 3 gives me 4 pi over 3. For the one in the fourth quadrant, let's move over here. The good thing is if you've done a good job drawing the triangle here and you know your reference angle is pi over 3, it's going to be the same reference angle when you draw it in the fourth quadrant. It's going to be pi over 3. This is opposite over hypotenuse. This would be 1. But more importantly, the angle that goes opposite the root 3 is the pi over 3. Once again, though, x would go from here all the way around to there. That's the angle that we're looking for. But we'll do it kind of maybe a little bit different here. I know from here to here is pi, but I've still got a long ways to go. So if I went all the way around here, which is 2 pi, also known as 6 pi over 3, then I could subtract and go back pi over 3. So my fourth quadrant angle is going to be 2 pi minus pi over 3. That's the same as 6 pi over 3 minus pi over 3, which is 5 pi over 3. And so those are my two answers between 0 and 2 pi. Let's practice another one. So I've got 2 sine squared x minus sine of x equals 0. That looks like something, it has sine in it, but notice there's a sine squared and just a sine, kind of like in the same way that if you had 2x squared minus x, what you could do is factor out the x. We can do the same thing here. I can factor out a sine of x, which will leave me with 2 sine of x minus 1 equals 0. And just like I would, if I were to finish this, if I had this times this equals 0, I would say either x equals 0 or 2x minus 1 equals 0. So I have either sine of x equals 0 or 2 sine x minus 1 equals 0. Let's work with this one. If I isolate sine of x is equal to 1/2, positive 1/2. And we know, according to all students take calculus, this time sine could be positive in either the first or the second quadrant. 1 or 2. You should recognize 1/2 as one of your trig ratios for one of your triangles. If I drew a triangle in the first quadrant where opposite over hypotenuse, 1, 2, this side must be root 3. It's the same triangle we were working with before, except the angle opposite the 1 is pi over 6. And in the first quadrant, not only is that your reference angle, since you're starting at 0 here, that is your angle. So that is one of my answers. In the second quadrant, same triangle. In other words, if you trust yourself here and you know the reference angle is pi over 6, it's going to be the same reference angle. You don't even have to worry about the sides. But this is our angle x now. So to get to this one, what I would do is go all the way around here, which is pi, otherwise known as 6 pi over 6. And then I want to subtract, go backwards by pi over 6. And that gives me 5 pi over 6. So I get these two answers from here. Now, if sine of x equals 0, you need to know that that's not a triangle problem. That is a graphing problem or a unit circle if you still want to use the unit circle. But if you reconstruct this graph, we've already done it on this note card here, I can tell from the graph that where sine of x equals 0 is at 0, pi, and at 2 pi. So how about I just put here from graph, or we were using the unit circle for a while. So if you like that, go ahead and use the unit circle. X is equal to 0, pi, or 2 pi. A lot of times you got to read the directions. A lot of times, let me go back to the top. This said, find all the answers between 0 and 2 pi, but not including 2 pi. The reason they don't do that is, you think about the circle. Here's 0. When you go around the circle, 2 pi is not the same as 0, but it puts you in the same spot. So it's kind of like counting it twice. So usually they won't have you include 2 pi. So we'll just take that one out, even though it works. And we'll go with these 4 answers right here. Okay, let's practice solving some more. 2 cosine squared x equals minus 1 equals 0. So your general strategy, if you can, is to try to isolate the cosine, isolate the trig function, or do some factoring as we saw in the previous one. But here, since there's only 1 cosine squared, I could move the 1 over, divide by 2, and I'm going to get cosine squared x equals 1/2. And just like if you're solving an equation that's x squared equals something, your next step is going to be to take the square root of both sides, remembering that when you solve an equation by taking the square root to get both answers, you want to make sure you do plus or minus. This one could be a little bit tricky in terms of recognizing which angle we're talking about. So let me go further here. The square root of 1/2 is the same thing as the square root of 1 over the square root of 2. And of course, the square root of 1 is just 1. So the square root of 1/2 is the same thing as plus or minus 1 over root 2. That you should recognize as, when we use our triangles, that's the ratio actually of either sine or cosine from the pi over 4 angle. But you also should know, if you don't use the triangles, you should also know, remember that this is the same. I'm going to put, or you could rationalize this. That is the same as root 2 over 2. If you're used to using the unit circle, you might recognize root 2 over 2. But if you're using the triangles, 1 over root 2 is fine. Okay. Now we do get this plus or minus, and according to all students take calculus, cosine could be positive in the first and fourth quadrants, but it could also be negative in the second and third quadrants. So because of that plus or minus, what this means is we are going to have 4 answers, 1 in each quadrant. Because there's going to be 1 in each quadrant, I'm just going to go in order. So I'm going to draw triangles for the first quadrant, second quadrant, third quadrant, and then our fourth quadrant. In the first quadrant, this cosine is adjacent over hypotenuse. This other side is going to be 1, and we just saw that that means this angle is pi over 4, which in the first quadrant is my angle. Second quadrant, same reference angle. So the angle we want here is here. So you've seen me do this before. I'm going to go all the way around, which is pi, but this time I'm going to think of pi as 4 pi over 4, and then go backwards, subtract pi over 4. So that gives me 3 pi over 4. Third quadrant, same triangle. That's pi over 4. X, though, to get it, I have to go all the way around here. So just like I did in the last one, that is also 4 pi over 4. But this time I'm going to keep going, meaning I'm going to add pi over 4. So that gives me 5 pi over 4. And then finally, in the fourth quadrant, same reference angle. You start to see, depending on which quadrant it is, how you always find the angle. If you're in the fourth quadrant, what you want to do is you want to go all the way around to here, which is 2 pi. In fourths, I'm going to think of that as 8 pi over 4, and then go backwards, meaning subtract. So I've got 8 pi over 4 minus pi over 4 is 7 pi over 4. 1, 2, 3, 4 answers. All right, let's keep going here. Tan x equals 3 cotan of x. How am I going to solve that? Well, we have seen, I can change things to sines and cosines. We've done that before when we were simplifying expressions. I could go that route. I could also notice that cotangent is the reciprocal of tangent. So 3 times the cotangent of x is the same thing as 3 times 1 over tangent of x. And then I might think, okay, well, then if it's 3 times 1 over tangent of x, if I multiply both sides by tan of x, cancels here, and I end up with tan times tan is tan squared of x equals 3. Like the previous problem, if it's tan squared, I need to take plus or minus the square root. So I end up with tan x equals plus or minus square root of 3. Again, plus or minus means 1 in each quadrant, right? All students take calculus. I've got 2 places where tangent's positive, 2 places where tangent is negative. So I'm going to have 4 answers again. And as far as what angle we're talking about, tangent's always a little bit tougher. Whoa, too far. There we go. Let's start with the one in quadrant 1. Because if you think of tangent, you usually think of opposite over adjacent, and all we have is root 3. So the trick is to just think of this as root 3 over 1. Root 3 over 1 is the same as root 3. But then it helps me because I've got opposite over adjacent, and that is precisely our special triangle. The hypotenuse happens to be 2, but more importantly, this angle is pi over 3. Just like the last one, there should be 4 answers. So if this would be a good time for you to practice, pause the video and see with that reference angle if you can find the other 3 angles in the quadrants 2, 3, and 4. Okay, so now I'm going to find them. I'm drawing these triangles so you can visualize this. You can probably imagine after doing a lot of this, you might even be able to do this in your head. Visualize the triangles. And that's kind of, if you can get to that point, that's really, really good. That takes some practice. Second quadrant, this is the angle we want. So what we're always going to do is go all the way around. That's 3 pi over 3. So that's pi, and then go backwards. Minus pi over 3. 2 pi over 3. In the third quadrant, what you're always going to do is go all halfway around, which is 3 pi over 3, and add pi over 3. And then in the fourth quadrant, you're going to want to go all the way around one full circle, which is 2 pi, which is 6 pi over 3, and then subtract pi over 3. And that's going to give you 5 pi over 3. Okay. At least one more here. Now I have, things are getting more complicated. 2 sine squared x minus 7 sine of x minus 4 equals 0. That looks kind of crazy, but what it also looks like, something that has quadratic form. That's something we talked about earlier, much earlier. And remember, to help you see it, and you can do this as an optional tool, to see the quadratic form, this to me, when I see this, this looks like 2 times something squared minus 7 times the same something minus 4 equals 0. So what am I essentially doing to get from here to here? I'm letting u be sine of x. That's 2u squared minus 7u minus 4. And that looks more like something we've seen before, something we could factor. I know it has to start with 2u and u. My last numbers have to multiply to -4, and I do have to get a -7. So we could play around here. If I put a 4 and a 1 there, this will be 8, this will be 1. So if I make this minus and this plus, that's going to give me -7u in the middle. Might as well keep going here in terms of u. So if I set each of these equal to 0, this will give me u equals -1/2 or u equals 4. But now what I should do is change it back to sine of x. So I have sine of x equals -1/2 or sine of x equals 4. Let's talk about this one first. Sine of x equals 4 might sound puzzling to you, and it should, because if you think about the graph of sine, which we graphed already before, we know it goes forever in this direction, but more importantly, the graph of sine always, the maximum it ever reaches is 1, the minimum it ever reaches is -1. So asking where sine of x is equal to 4, you can see there's no place where the sine graph is going to ever intersect 4. Right? This is impossible. There's no solution to that. So if someone was asking for the sine of x, it's going to have to be a number between -1 and +1. That's a good thing to know. This just has no solution. I don't have to worry about it. But sine of x could equal -1/2 in sine is positive in the first and second, so it must be in the third and fourth quadrant, or fourth. Third quadrant, -1 opposite over hypotenuse. That's the √3 on this side. So this angle is pi/6. 6 pi/6 plus another pi/6. This gives me 7 pi/6. And in the fourth quadrant, same triangle. So this is pi/6. So now I'm not writing it down anymore. I'm going to go all the way around, do this in our head. That's 2 pi, which is 12 pi/6. And then subtract, meaning go backwards by pi/6. 12 pi/6 minus pi/6 is 11 pi/6. Mm-hmm. So those would be the only two answers to this equation. So hopefully this is making sense. And again, I'm not using the unit circle. Everything, if you know the triangles and you know your trig graphs, you can answer everything. It might look a little longer to you than if you've been using the unit circle in the past, but it does get faster as you practice doing this. You will be able to get these angles faster. So keep at it.